As we continue the second part of this chapter, we will go to lesson 7.4, which is the application of linear systems. To apply this, we need to be able to choose the best method for solving the linear systems. In 7.1 through 7.3, we were given 3 different ways of solving a linear system. 7.1 was graphing, 7.2 substitution, and finally 7.3 was linear combinations, which was the useful method when none of the variables has a coefficient of 1 or -1. We'll start out with the first story problem and try to see if we can choose the correct solution method or the most appropriate one. Example 1 is about selling shoes. A store sold 28 pairs of cross-trainer shoes for a total of $2,220. Style A sold for $70 per pair, and Style B was $90 per pair. How many of each styles were sold? First, we're going to look for the totals that we are told in this equation. The two totals, the information we are given is we know that there was a total of 28 pairs, and we also know that there was a total of $2,220. I'm going to set up our two simple equations. First of all, for the total of pairs, we'd have to do the number of style A plus the number of style B would equal the total number of pairs. This is where I will find my first simple variables. X plus Y equals 28. For our next step, we'll look at the other total that we were given, 2,220, and this has to do with the total amount of sales. When we look at that, we're going to need to take the price of each style of shoes plus which style it was. So the price of style A, which was $70, times the number of shoes, which we're still not sure of, so that's the variable X from our first equation. We're going to add that to the price and the style of B, so that would be $90 times Y, which is our variable representing style B, and we know then with the prices that we would get our total sales of $2,220. Now that we have our two equations, we need to decide on which method we will use to solve this. Because our first equation has two variables, x and y, and both of those variables have the coefficient of 1, substitution would be the best method of solving. I'm going to take the first equation and I'm going to go ahead and I'm going to set it to solving for x. X equals 28 minus y. In doing so then, I can use the substitution method with the second equation. Instead of 70x, I can substitute in the quantity that we just said of 28 minus y. We still would add the 90y and have the total of 2,220. This is a method of solution because now we have an equation that involves only one variable. We would need to distribute that 70 to the quantity that we replaced as x, and that would be 1,960 minus 70y, plus the 90y we already had in the equation equals 2,220. Now we have some like terms to combine. I went ahead and I took the constant term here, 1,960. I subtracted it from the constant term on the other side of the equal sign, resulting in 260. I combined the coefficients, negative 70 plus 90, and have the new coefficient 20y. So now 20y equals 260. I would continue with my balanced equation and divide both sides by 20, giving me the result of y equals 13. That's the first step in substitution. Now we have an actual amount for one of the variables. Because of this, I can decide to substitute for the second time into one of the equations. I will pick the simpler one, which was the x plus y equals 28, equation 1. In doing so, I can substitute my y value, which is 13, replace and put my x variable back in there because I need to find the value of x. So we have x plus 13 equals 28. I won't bother showing the balanced equation there, we can go ahead and solve that mentally as x equals 15. So one more time, because the coefficients of x and y were both 1 in equation 1, substitution was the most convenient. We solved equation 1 for x and substitute the result into equation 2. Simplify to obtain a numerical value for y equals 13, and then do substitution one more time, picking either equation, usually the easiest one, and substituting 13 for y, again having one variable to solve for. And when we solved for that, we got x is equal to 15. Oh, you